Stupendous siren coders, it's Prof G, and we are here to show the solution for the Who Moved My Stuff alarm. That's our challenge from the previous lesson that triggers an alarm if someone jostles an object that they shouldn't go near.
And we'll see if somebody tries to nab my iPad. Whoa, we caught him red-handed.
Now, while we'll show the solution, we'll also introduce a couple of new techniques, including the use of compound conditionals with parentheses and using the absolute value function. Let the awesomeness begin. And now to begin, plug in that CircuitPlayground board, Bluefruit or Express. Start up PyCharm. If you're new here, welcome. You may want to check out the prior lessons in the playlist to see how we got to this point. Also note, I'm assuming everyone here has a CircuitPlayground Bluefruit or Express with a folder named Alarm that contains a WAV file named Siren on it. If not, you can download the alarm folder from the open Google Drive at this URL, bit.ly/CircuitPython-school-files, all lowercase. Now let's code, and the accelerometer code that you're seeing here is from where we were at the end of the last lesson. And I'll set the comment up top to Who Moved My Stuff Alarm with dashes. That's going to be the name of the file when I eventually save this as a backup. And we're going to need to import two libraries as well, digital IO and NeoPixel. Now, if you copied and pasted code from the fridge alarm, totally fine. I'm going to enter the code from scratch, although I'll do a little bit less explanation than I normally do because we've already covered this in previous lessons. Now, we also need to import the WAV file class from AudioCore, so we'll say from AudioCore import WAV file with a capital W, capital F. Now, next is a block of code that will import the right library for playing back audio depending on your board. So if you know the library that you want to use and you don't want to run code on another board, you could just import the file that you need. It's the audio IO line I'm about to write if you have a CircuitPlayground Express board, or the audio PWM IO line I'm about to write if you have a CircuitPlayground Bluefruit board or a Raspberry Pi Pico. But if you don't know or you don't mind typing a bit of extra code, if your board supports audio, this next block of code should work. The difference in the boards, by the way, is that boards like the Express have a built-in audio circuit. That's called a DAC, D-A-C, for digital analog converter, whereas the others require a different technique called PWM, which we'll discuss later. So the code for all boards is try, and then indented it's from audio IO space import space audio out with a capital A, capital O. Either this is going to work or it's going to throw an error. And if it throws an error, we'll outdent and we'll say except space import error, capital I, capital E, return indented. Then we'll have another try statement, try, return. And this is another thing that might or might not work or give an error. We'll say from audio PWMIO import PWM audio out. That's with a capital PWM A and O. I just typed audio out, but you can see code completion suggests PWM audio out. I'll select that as audio out, capital A, capital O. If this doesn't work, we have except import error, capital I, capital E, return, and indented below we'll have a print statement. This board does not support audio. Copy and paste this block of code, and you'll be guaranteed to import the file that you need, regardless of whether you know you have a DAC or not on that board. Or, of course, you can consult the documentation. The nice thing about this block of code is, since CircuitPython runs on hundreds of boards, and this will make the choice of the right file to import, you can just leave this code as is. Next, let's set up our NeoPixels. We'll use the familiar line pixels equals NeoPixel, lowercase, that's the library, dot NeoPixel, capital N, capital B, passing in board dot NeoPixel, all cap, comma 10, since there are 10 NeoPixels on board. And we need two colors in all caps red equals in parens 255, 0, 0, and all caps black equals in parens 0, 0, 0. And then how about above this, we set up the speaker for the CircuitPlayground Express or Bluefruit boards. So if you use the built-in speaker on either the Express or the Bluefruit, you need these three lines. We'll call our variable speaker, set it equal to digital IO dot digital in out, capital D, capital I, capital O, and in parentheses, we're going to pass in board dot speaker underscore enable. Make sure you got the enable option. Then below this, we'll take the speaker object we just created and set its dot direction property equal to digital IO dot capital D direction dot all caps output. And finally, we set the speaker.value property equal to capital T true. Then we'll use the speaker location to create an audio out object named audio. So that's audio, all lowercase, equals audio out, capital A, capital O. And we pass in the location board dot all caps speaker, and just speaker this time, not speaker enable. Then let's set up the path where the sound files can be found. So we'll say path equals, and in double quotes, the name of our folder is alarm. Keep the slash in here to separate the folder from the sound file, and that's all lowercase. Again, make sure that you've got a folder named alarm on your board with a file called siren.wav inside. Then we'll create our two buttons, and you know the drill. Button underscore A equals digital IO dot digital in out, capital D, capital I, capital O. Between parentheses, we'll pass in board dot and in all caps button underscore A. Then we'll take that button underscore A object we just created and use dot switch underscore to underscore input, passing between parentheses digital IO dot capital P pull dot all caps down. With this button created, we'll copy these two lines, paste them down below, and switch the three button A references to button B. And you might recall from the fridge alarm, we create a variable named armed, and we set this equal to a capital F false so that the alarm is initially unarmed until we press button A in the while true loop. And another thing we should do is set the pixels brightness and fill values for our NeoPixels, and why don't we do that just below where we set up our colors. So we'll say pixels.brightness equals 0.0 and pixels.fill passing in all capital red. And I'm realizing now, even though we created a color black, we're actually not using that. We're just changing the brightness from full down to 0. And so now above while true, why don't we create a function to pulse our lights from brightness 0 all the way up to brightness 1 and then back down to brightness 0. So we'll say def space pulse in lowercase, open and close parens, colon indented below. Our first for loop is for I in range 101. It'll go up to 101 but won't reach it. Colon, then we'll say pixels dot brightness equals 1/100. And the reason why we do this is that pixel brightness is from 0.0 to 1.0, but range has to be in integers. And then below this, we'll outdent and add our other for loop, which is for I in range. And in parentheses, we're going backwards. So we have a 3-value range, 100 where we start, comma, -1 we go up to, but we don't reach this, comma, and we increment or we step by -1, colon at the end. And we also say pixels.brightness equals I/100. Then below this outdented, we're going to create our play sound function. So it's def space play underscore sound. In parentheses, we'll pass in file name, colon, and indented below, we'll say with, open in between parentheses, pass in path plus file name, that gets us to our file, comma, in double quotes RB, it reads in the binary values, and this is going to be as, and then the name of the variable that we're creating here is wave underscore file. Make sure you got the colon at the end. So this creates a wave file variable containing data from the file. Then indented below this, we're going to create another variable called wave, all lowercase, equals wave file. So this is a class, capital W, capital F, and we pass in wave underscore file, the value that we created above. So this converts a usable .wav file that can be played, and we play that in the next line, audio.play, passing in all lowercase wave, that value that we just created. Then below this, we say while audio.playing, colon, and then if we are playing, we're going to call pulse, open and close parens. That'll call the pulse function above, and it will pulse the lights up and down as long as the audio is playing. If not, it will stop playing, and we'll head back down to the while true statement to see what we should do next. Now in while true, we want to react to button presses. So first we'll say if button underscore a dot value colon, that means if the button's pressed. Why don't we print out the line armed, and then we'll set the armed variable equal to capital T true. Then we'll time.sleep, passing in 5.0, which waits 5 seconds before we check on movement. Then below this, we'll respond to button B with if button underscore B dot value colon, indented below, print disarmed, and we'll set the armed variable equal to false. Then below this, to check on motion, I check to see if the X value or the Y value was either less than -1 or greater than 1. Now you could write this with a series of if statements, but I'm going to show you how you can do it in just one statement. Now some of you might have had some variant of this. Check to see if armed was true and X is greater than 1, and if so, play sound. If armed is true and X is less than -1. If armed is true and Y is greater than 1. If armed is true and Y is less than -1. But here's a way to accomplish this in one if line. We can say if armed and then I've got a set of parentheses for another compound conditional in here, where we're going to check to see if the absolute value of X is greater than 1 or the absolute value of Y is greater than 1. Now, a few things. One is it's totally fine to nest compound conditionals like this. So what we're going to do is we're going to evaluate this OR statement here in parentheses before we evaluate it with the AND statement here. Now, second, we never discussed the absolute value function, so I didn't expect you to know that. It's just ABS, and if you remember from your grade school math, absolute value just gets rid of any negative signs if there are any. So regardless of whether we were less than -1 or greater than 1, abs checking that value will cover both conditions. And we do this for both x and y, so or means the value between this first set of parentheses here will be true if either of these statements is true. I could have checked the z-axis as well, but really, you're not going to keep x and y perfectly steady while you lift something up in the z-axis, so this is going to be perfectly fine for our purposes. So again, our code in the while true statement, outdented so that it's even with the other if statements, is going to be a statement that says if armed and, in between parentheses here, we'll say abs, between parens pass in lowercase x, greater than 1, or abs, parentheses, lowercase y, greater than 1, colon at the end. So that detects if x or y is jostled a bit, plus the value's armed, and if that's true, we're just going to play underscore sound, passing in between double quotes, siren.wav. And I happen to have this nicely formatted print statement from the previous example. I'm just going to make sure that this is indented below my if armed and statement above, and I don't need time sleep 0.1 below that. We don't need to delay anything. So let's open the terminal, get into TO. These numbers are from the previous example, so let's save up top. We see our new code is running, and now let's check out what's happening on our board. Now I'm going to test this set up next to a phone charger. My kids are regularly nabbing my phone chargers. So what I'm going to do is press button A. So you see the two different buttons on this. This looks like button A. And then I get 5 seconds to arm it, so I'll leave it where it is. And then if somebody tries to steal my phone charger, oh, there we go. Just jostled it a little bit. I'll hold this down to turn it off. And now normally what I would do is I would use a battery pack to this, or if it was the kind of phone charger that could power my CPB. Some of them do power boards. Other ones, unfortunately this one, will cut off its power if it doesn't receive any power out requests from a device for about 20 seconds. But many of the phone chargers actually can be plugged in right in here and used remotely. But let me go ahead and press A again, and I'll wait 5 seconds. And then let's imagine somebody from my family sneaking in, and they set it off. Look at that, so just a tiny bit. So it may turn out that the one that I set this at is too sensitive, and so you can adjust those values, but we can absolutely see it works. Hopefully you got that. If so, nice work. If not, feel free to rewatch the lesson and rewatch the video solution until you got it down. When I rewatched this and took a look at the output, there's one thing I would have changed. I actually put my print statement after play sound, and I should have put it before play sound because this way the results would show before it started to play sound and before it went through the pulse, so I could see what the values were before the alarm started to go off. The way it is now, I'm not going to see the print results until the sound file is done playing through one iteration. So the logic of this could be improved. You might want to try moving the print statement above play sound and then take a look at your results. Also, disarmed shows up a bunch of times because we're not using debounced buttons, but that's totally fine. Nothing in the challenge asked you to print out anything. I just happened to add these when I was showing you the solution. So let's close up the terminal and save this to our CircuitPython school folder as whomovedmystuff.py. Close that extra tab so you're back at code.py, and we had big learning. We learned how to use even more compound conditionals and the absolute value function. I hope you feel good about that little bit of awesomeness you just built. Keep coming back because there's more big learning to be had. Continue to hack.